So here we're going to review the substitution and elimination reactions of alcohols. We've already seen most of these. SN1 reactions occur with tertiary alcohol. As shown here, we have a nucleophile that will attack a proton, and this makes a good leaving group. Then we'll have the bromine will attack the carbocation, and we end up with our product. SN2 reactions also occur. Primary alcohols will react with hydrogen bromide. The nucleophile attacks the proton, and then this makes a good leaving group so that the bromine can attack the carbon here. For hydrogen chloride, a catalyst has to be used, and so you have to have this zinc chloride, and it's ionic, and so it has to be water soluble. You can only use this then with smaller alcohols that are water soluble. And again, we have an alcohol that's going to attack the zinc this time, and then this makes a good leaving group so that the chloride can attack the carbon at this position. Alcohol can also be converted into a tosylate, and that makes it a very good leaving group. And these are the reagents to make a tosylate. Primary and secondary alcohols will react with thionyl chloride and phosphorus trichloride. This is going to be very similar to the tosylate that we looked at, but it's going to make the chloride, or the phosphorus trichloride makes chloride, and the phosphorus tribromide makes the bromine. Okay, so let's look at the skill builder and see how we're going to approach it. We're supposed to identify the reagents to accomplish the following. We'll want to analyze the substrate, then we'll want to analyze the stereochemical outcome, and then lastly we'll look at the reagents required. Our substrate here is secondary, so an SN2 process will be required. There is an inversion of configuration. Here the hydroxy is coming toward us. On the product, the chloride is going away from us. So inversion is required, is evident, so we'll want to have an SN2 reaction for that reason as well. Rearrangement would also be a problem if you tried to do an SN1 reaction. If you made a carbocation at this location, it would want to rearrange and shift down to here. Then we want to identify the reagents required. You'll of course recall that the hydroxy group is going to be a poor leaving group, so we're going to first want to treat with tosylate and then sodium chloride. Or we could use the thionyl chloride. We cannot use hydrochloric acid and zinc chloride because this alcohol is not expected to be water soluble because it has 8 carbons. E1 and E2 reactions. So alcohols will also undergo elimination reactions under acidic conditions. So first we'll have a proton transfer. That gives us a good leaving group, and a carbocation can be formed, and then elimination can occur. So an E2 pathway can also be used, but first we're going to have to make the hydroxy into a better leaving group with the tosylate, and then we'll use a strong base. This will form the more substituted alkene unless the sterically hindered base is used. Next, we'll be looking at oxidation.